In this video, we will introduce you to two common uses of heatmaps. The first one is website heatmap. This one's more complicated, and we will just give you a brief idea of what this application is and how it is often used, but we will not give you the detailed demonstration of how we can do it ourselves. And the second one is correlation plot. And this one is fairly simple, and we will give you concrete examples of how to create your own correlation plots.
Here I'm introducing website heatmaps. Website heatmaps are a way for web designers and marketers to visualize how customers or prospects interact with their applications. They highlight the parts of the website which visitors are paying the most attention to. And there are many kinds of website heatmaps, including the click heatmaps. Here the picture is showing the click heatmaps. Click heatmaps show where users click on a web page. The areas with most clicks are typically displayed with warmer colors, such as red or orange, while cooler colors like blue or green represent fewer clicks. And there are also kinds of mouse movement heatmaps, scroll heatmaps, attention heatmaps. Mouse movement heatmaps track the movements of the user's mouse cursor. They can reveal areas of interest or confusion as users navigate the page. And scroll heatmaps illustrate how far users scroll down a web page. They often use color gradients to show the distribution of scrolling behavior. And attention heatmaps combine various data resources such as clicks, mouse movement, and scrolling to provide a overview of user engagement and attention on the web page. And the website heatmaps also have two illustrating ways. That is static and dynamic. Here, the screenshots illustrate the static heatmaps. This is also a click heatmaps that the warmer colors show where the customers pay more attention to. Obviously, shares and licensing are more in favor of the customers. And another is dynamic heatmap. This is a more interactive way for users and the web designers. Dynamic heatmap allows analysis of all kinds of pages, including static pages, pages with drop-down menus, and intuitive elements that change as per user command analysis. Heatmap is overlaid on an interactive website. The heatmap updates dynamically as per the interaction, like clicking the menu bar.
I will introduce you to two ways of creating correlation matrix in R. The first way is to use the function corrplot, and then we need the package corrplot for this purpose. The second way is to use heatmap function, which is in the base R package, but we would need to pass in some sort of color plate, and I will use the package R color brewer for this purpose. First, let's just import some data. I just choose some random data set with numerical variables. And I will only use the first 10 because it will make the plots clear. And the main purpose of this video is just to show you how to create correlation matrix, so I don't have to include all those variables and make it messy. Let's first see how to use corrplot function. We first import the library, and then we create a correlation matrix. It's simply just use a core function, which is in the base R package as well, and we pass in the numerical variables we want to use. Then with this matrix, we pass it into corrplot function. We can change the method, and then the first one I show here is just a circle method, which uses a circle, and the size will be the magnitude of the correlation. Another one is ellipse, which I really like because the way it tilts shows that whether the correlation is positive or negative. Another thing we can choose is the type of the matrix, because we can only show the upper half or lower half because we have a symmetric matrix. And another method is number, which can show us the exact value of correlation between the variable pairs. And we can also change the order of the variables. And this one I just set to be the components in the first principal component, because the one that comes first will be more important per se. And we can just delete the later ones that have high correlation with previous ones. Then let's move on to the heatmap function. We first import the library R color brewer, and we want to choose some plate from it. And the one I choose is just the red-blue one. But we need to be careful. It needs to be a divergent one because we have positive and negative values. And then we pass it into the heatmap function. We use the correlation matrix we created before as well. And then we pass in this color plate, and we set this variable symmetric to true, because we have a symmetric matrix.